Hello everybody, my name is Mark Lee and today I'm going to give a video demonstration of my final year project which is titled The Development of Automated Test Suite to Test COVID Contact Tracing Apps. After some discussion with my supervisor, we decided the best approach to systematically test the UI of the system under test was to apply a model-based testing approach. The two system under tests were the NHS COVID-19 app and the Protect Scotland app, both on the Android platform. Model-based testing is a form of black box testing used for test case design, and it represents the behavior of the system under test using behavior models. For this project, I used the model-based testing tool GraphWalker, which uses extended finite state machines to design the test models, which represent the UI flow through different pages of the system under test. Before beginning a live model-based test run, let's take a look at the models that were designed. To access the models, on the GraphWalker Studio tool, you need to first run GraphWalker Studio jar, which you can see here. It's currently running at the moment. Then you can navigate over to port 990 under localhost. Each tab is a model which represents a distinct page of functionality within the system under test. For example, the home model represents the home page of the NHS COVID app. The models are made up of nodes and edges, with each node representing a state and the edge representing the action taken to transition between said state. For example, if you're in the home page and you want to click on the settings button, which is represented by this edge, it will take you to the settings page where you will verify the action has occurred and that you're now in the settings page. To transition between test models, use the shared nodes, which are highlighted in orange, which will jump between other shared nodes with the same shared name tag. An example of an action and guard usage can be seen in the home model, where the tracing active and self-isolate variables are set to true and false by default. So when you click on the turn contact tracing edge, you can see it is blocked by the tracing active guard. If the generator traverses through the turn contact tracing off edge, as you can see here, it will turn the tracing active variable to equal false, meaning you can now access the turn contact tracing on edge as it will be no longer blocked. GraphWalker is integrated to our Java-based project via GraphWalker Maven dependencies. The node and edge behaviors are implemented using the Appium automation framework. And the system uses GraphWalker annotation, as you can see here, in order to label GraphWalker tests with your desired traversal algorithm and stop condition set. After some testing, I decided to use the weighted random traversal algorithm. Before beginning our live model-based test suite demo, let's look at an example of the Appium Java code which implements the abstract test cases created by GraphWalker. The Appium test code was created to mimic various user actions on the system under test, like clicking, scrolling, and entering text. The system used the UI Automator 2 Android driver with other Android libraries such as UI Scrollable and the Android Debug Bridge command line tool, which can be used to communicate with the device. Here's an example of the node and edge behavior implementation for the home model using Appium Java methods. As you can see, verify in homepage node here, which corresponds to the verified homepage node on the test models. So if we drill down into the check in homepage method, it is declared in the homepage class, which contains the locators and the various methods that are called for each node or edge test case in the home model. The check in homepage method passes various UI elements that you expect to see on the screen and inserts if they are present or not. For verifying in the homepage node, it is the check in button, read advice button, and status banner. The WebDriver waits for visibility of the locators before throwing an error. Okay, first I'm going to run the NHS COVID model-based test suite. The test started in the GraphWalker COVID-19 test class. You click on this green arrow here to kick off the test. This will also start a live WebSocket server on port 887 where you can visualize the test, which we're going to do now. So I'll navigate over to GraphWalker Studio and check for port 8887 and connect. It's now connected. Test is about to begin. Begins on the NHS onboarding model, as you can see here. The test is now kicked off. This is a screenware app of my phones showing live visualization of the test as it happens, so you can compare each step it's taken in the model, and then what is happening on the system under test. There's a total of 12 models and 71 nodes on 138 edges for the NHS COVID-19, and the execution usually takes anywhere between 1 and 3 hours. I'll come back when the test suite has finished and reached this desired stop condition of 100% edge coverage. As you can see, the test has now finished after 1 hour and 32 minutes. The test result was successful and the mail has been sent to your configured email address with the enhanced output log. Let's take a look at the enhanced Excel output log just produced. As you can see, there is a test path duration sheet. It contains every step it took to reach the stop condition, and any failures will be marked in the failures column. Both system under test for this project were well designed, and I did not experience any faults. There are other key metrics in the other two sheets which show the number of steps in each model. In this case, there was 1,523 steps, which took a total of 1 hour and 30 minutes and 56 seconds. Next, I'll kick off the Protect Scotland model-based test suite. This is in the GraphWalker Protect Scotland test class. It's the same process as before. I'll click the play button here. This will also launch the WebSocket servers. Test has just begun on the Verify in Edge page node. This is the edge confirmation model, which will move on to the location model before it gets on to the onboarding process, and then it'll get into the home model. I'll speed up the execution and come back when this is finished. The text execution is now finished, and the same automated email is sent with the results, and the enhanced Excel output log is also attached, as you can see here. Text execution took a total of 1 hour and 12 minutes with 3,870 steps. And looking at the simple output log, it achieved 100% edge coverage as was required as a stop condition, and it visited a total of 114 out of 114 edges and 69 out of 69 vertices. To finish off, the most technically difficult aspect of the system could be several things. For example, model designing from scratch was a new skill I had to learn, and is a challenging process in order to represent a large mobile application's entire GUI. This required a high-level architectural understanding of both system under tests. Also, there was many technical components, mainly under the hood, which I had developed in order to achieve Android automation which matched the needs of the test cases. This resulted in me producing many custom UI helper methods, such as scroll define element or programmatically perform A to B commands such as clear app cache or getting system properties from the test device. Regarding my main achievement of this project, I feel I incorporated many technologies and frameworks to produce comprehensive test suites, which improved test case design via model-based testing, which has demonstrated a proof of concept of model-based testing in the Android domain, which could be used in its current state by respective app developers in order to perform regression testing and UI testing. If I was to continue development of this project in the future, there are two main features that I would like to add. First of all, I would like to incorporate iOS implementation, and this would be possible as the test models were designed with a high level of abstraction, but the test code would need to be implemented using the Albion Xcut driver instead of the Android UI Automator driver in order to perform actions on an iPhone. Also like to perform more in-depth comparison of the traversal algorithms offered by GraphWorker, as I was only able to perform limited testing on 3 options due to time constraints. Finally, I would like to thank you for watching my video presentation.